Here we go with the next part of the lesson. This section is called Something Old and Something New. In today's society, we tend to forget how we know the things we know, and we take it for granted. In the renaissance of science, meaning back when we started thinking scientifically, we didn't know what we were made of. We didn't know what atoms were. We didn't know what cells were. We believed in things like if you leave a bunch of laundry in the corner, that it will make mice, so that the mice came from the laundry. People believe that. Um, so things like that, that were passed down were hard beliefs to get rid of. And when we started to think about things in a scientific way, taking measurements, repeating our experiments, um, talking together with our peers, revising our experiments, we started to learn that laundry doesn't make the mice, or hay doesn't make the mice. And so we need to take a step and look at how we know what we know about the atom. It's not just because Dr. J says. I hope you giggled. So here's a breakdown of kind of what your textbook goes over. That before Dalton, we had the other guy with the plum pudding, J.J. Thomson, and with what he came up with, oh my goodness, kind of tied into Dalton's theory that the atom was just a bunch of empty space. And then Thomson came along and said it's kind of like plum pudding, where you have the protons and neutrons mushed around throughout the atom. And then Rutherford came along. He did some experiments. He just didn't sit down underneath an apple tree and the apple fall on his head and say, "No, it's like this." Rutherford actually did some experiments to support his model that he put forth, with the protons and neutrons being in the nucleus, being the center part of the atom. And so as we started to learn more, we built on each of these scientists' contributions to what we know about the atom and how we think about the atom. So after Rutherford came Bohr. And Bohr came up with this idea that electrons orbit around the nucleus in shells or energy levels. And so if you remember when the gizmo build an element, that the first energy level holds 2 electrons. And then after that, to have a stable outer shell, we want 8. That's good for us here in our level of understanding of the atom. When you get to high school or AP chemistry, you're going to learn more about orbitals. It'll probably take your mind and go like S, P, D, and F orbitals. But for us, 2 in the first shell, and then the next 2 shells after that are going to have 8 to be full or stable. Then we come along with our current understanding of the atom, with the center of the atom being positive, with what we call an electron cloud. So in the Bohr model, we have these nice distinct energy levels where we modeled where the electrons were. But we've learned with more technology and more experiments that is actually everywhere in this cloud is a possibility for the location of an electron. And they move so fast that it's hard to pin down exactly where they're at any one moment at time. So we go from empty space to altogether like pudding, to protons and neutrons in the nucleus, to the electrons are going around the nucleus, to instead of these distinct locations, that the electrons are actually in these cloud-like areas. So question number 7 asks you to underline the 4 main ideas of Dalton's theory of the atom. And this is a illustration of what plum pudding looks like and Thomason's model. I have never eaten plum pudding, and I doubt if I ever will eat plum pudding. I'm not a fan of plums, but I think it's a very European common dessert. And so this is what he proposed, that mostly empty space with the protons and neutrons and electron embedded within it. Plum pudding. Never seen it before. I'm probably not going to eat it. Okay. I might try it once just to say that I did. And maybe someday I'll travel to Europe. Maybe. I hope. It's on the bucket list. There's still time. Okay, question number 8. It asks you to describe how you would show J.J. Thomason's model of the atom using small beads and clay. So, if you were going to do this model as a project in class and I gave you clay and beads, you would have to tell me how you made it and then tell me what each of the pieces meant and why you arranged it that way. So make sure that you're describing how you'd put the model together and what the pieces mean and why you arranged them that way. So here's a GIF that goes through the different thoughts on the atomic model. So we start out with the plum pudding model, the orbits to our electron shells. So number 9, ask you about today's model of the atom looks different from the models that came before it, all the ones that we just talked about, from the empty space plum pudding to the nucleus to the electrons orbit around the nucleus to we have orbital energy levels to the electron cloud. And they ask, why has the model of the atom changed? Is it because we got smarter? Is it because more people are thinking about it? Is it because the people with those first ideas are dead and can't defend themselves? Why do we have this accepted model of what an atom is, um, with the protons and neutrons being in the center and the electrons being in these electron cloud areas? And so this is an example of that electron cloud, with the blue being the nucleus. And then the electrons are moving so fast that it's hard to pinpoint them down to exactly one spot. But you can see that if we were to map all their random positions, that we'd have this cloud, this distinct energy cloud around the nucleus where this orbital shell would show up. So it could be any of those places that this purple is. That's the electron cloud, meaning that the probability of finding the electron can be anywhere in that purple region.